Hi, this is Lewis from Rossman Repair Group. In this video, in a couple of minutes, you're going to watch me as I solder and desolder a QFN component from a board, and the camera is going to be zoomed up right on the board, so you can see exactly what I do. Now, I'm going to remove a backlight chip from a Unibody Macbook motherboard and put a new one on, with the hopes that I actually get backlight. We've ultrasonically cleaned this board, and it still manages to blow the backlight fuse anytime a new one is put on. Now, there are a couple of videos on how to do QFN soldering on YouTube, but none of them involve a computer motherboard, which is interesting to me because there are a lot of them that do ball grid array soldering of graphics chips, there are a lot of them that do DC jacks, and there are a lot of them doing basic fuses and resistors and other standard small components. But I couldn't find any doing QFNs on a motherboard for an Apple computer. I see a lot of them for single layer boards, for let's say audio equipment, and I see them with testing boards or learning boards where you're running solder through a channel to a larger QFN chip, and it's just not the same. If you watch one of these videos, it makes it look like it's incredibly easy. Just apply that technique, and you'll be smooth sailing. And if you've tried to do that and you've wound up here, it's probably because you've realized that those techniques are worth jack shit when dealing with an Apple motherboard. Because again, the pads are smaller, the chips are much smaller, and the board is much more populated along the sides. Now, I'm not saying this is the only way to do it. I'm just saying that if you're a beginner, it can't hurt to watch somebody do it on the exact same board that you may be about to work on. Now, a couple of disclaimers. The first is that this is going to be an unedited video. That means that if I fuck up in any way, I'm not going to edit it. The only edits that are going to be placed here are due to the 5-minute video recording limitation of this Nikon camera that's meant for photographs, not video. So if I make any mistake, you'll be able to see it, which is actually good because people who are doing something for the first time are inclined to mess something up. This way, it'll show you where you should be more careful, and it'll also show you how to fix whatever you fuck up should you happen to fuck something up. And there's a good chance that I may fuck something up for a couple of reasons. The first is that it's 3 in the morning, and I start work around 9 to 11 in the morning. So I've been working for about 15 hours now. And this is what I do all day. So not only have I been doing this all day up to this point, but I've also been doing this from the sunrise to 8 hours after the sun has gone down. So I'm incredibly tired. It's amazing that I'm even still awake. And the second thing is that I don't have a steady hand. My hand shakes very often when I'm holding something very still. If I try to hold this pen like a soldering iron, in focus, and keeping it steady, it won't stay steady. So the point being, if I can do it, then you most certainly can do it. You just need a little bit of guidance. And the third thing I'd like to point out is that the reason in which I'm not going to be using the standard QFN or BGA soldering tactic of running flux along the pads and running a solder ball around those fluxed up pads. I've noticed that with new hires and trainees, they often, somehow, don't ask me why, they manage to rip the pads off in doing it this way. And I don't want you to wind up ripping a pad off doing it that way. I like doing it that way. It helps me get the work done faster, but I'm going to do it the slow way, which is going over each individual pad after putting flux on it. I'm going to go over each individual pad. I'm going to clean the tip of the iron after going over a couple or even each individual pad if necessary, and make sure that the excess solder gets put on the iron, and make sure that each pad looks good. Again, you can disagree with this. I don't even agree with using this tactic. I'm only using it because it's simple and it's easy for somebody who's a beginner. That being said, let's get on to the soldering. And if you have any questions, comments, ideas, feel free to post them in the comments, and I'll reply. Alright, this is an A1342 MacBook, the white unibody motherboard. This is the chip that controls or drives the backlight. So that's what we're going to have to replace here, since there's no backlight and it repeatedly blows the fuses as we replace them. The first step before replacing it is to prep the board. Now, see all this little crap over here? That is around. And also there's one that's actually missing over here. Lovely. And there's all this nonsense. This all falls off very easily because you need quite a bit of heat to remove these QFN packages. It's possible that this has been worked on before. You never know. That's a good hint. It could have came off when it got liquid damaged, The thing's been ultrasonic to clean off all the crap on it. It still blows fuses. So next step is this thing. Now, this orange tape is called Kapton tape. It's spelled K-A-P-T-O-N. Kapton tape is heat resistant. So if I put this tape over here, the components under it are not going to get hot enough to get moved around by the hot air station here. This is important because the last thing you want to do at 3 in the morning is hunt down which one of these is what type of component. Are you a you a 0.2 ohm resistor or a 4 ohm resistor, just so that you could try to find one and put it there and hope that that's the only thing you blew off. You really don't want to deal with this shit at 3 in the morning, so it's best to just put this tape around all the crap that could potentially fly away. Even though this other stuff is larger and slightly further away, I am covering it because I don't want to deal with it flying away. Now that those components are covered, we can get to the next step, which is preheating the board. I'm waiting for my hot air station to heat up here. Now, a lot of the videos that you may have seen have single layered boards. I know because I've looked before making this video, meaning that there's nothing going on in between this layer and that layer. Not only do these boards have many layers, it's also adept at absorbing heat. This entire board is comprised of heat producing components. You have graphics chip, a CPU, voltage regulators. This board makes a lot of heat. In addition, now one thing that makes this board different than the other board, or those test PC boards or training PC boards, this board absorbs heat. It's designed to absorb heat. Underneath each one of these QFN packages is a heatsink that absorbs heat, because this here, in a way, is an amplifier. Those heat sinks absorb the very heat that we need to heat the solder pads next to it up to remove the chip off the board. And this creates problems. In addition, this is also a complicated PC board with many layers to it, and many of these layers also happen to absorb the heat that we're trying to use to heat the chip. So if you just run up on the board and put your iron over here like this and expect to pull the chip off the board, it's not going to come off. Further, if you shock the board with a high level of heat, or you shock this chip with a high level of heat, it's not actually going to work afterwards. This chip, assuming this chip was good before, it will be dead. You'll notice it start to rise at the top and bevel until it finally cracks. You need to have every component heated evenly. Just because this chip is 400 or 500 degrees doesn't mean it's going to come off the board if the solder pads themselves are not hot enough to actually melt, because all the heat's being absorbed. What you want to do is heat all of these layers evenly. I want the middle layer of the board, I want the bottom of the board, I want all the stuff around it to not be at a high enough temperature to melt solder, but I want it to be right on the cusp of being able to melt solder, so that when I do finally decide to go in on this chip and heat it up enough to remove it, it only takes a couple of seconds, and I'm not using a really high temperature to do it. So let's go ahead and get to removing the chip. Right, and when the iron is heated up a decent amount, we're going to start with preheating the board. So about like 1 or 2 inches away. I'll hold the iron. I'm going to adjust my chair here so it doesn't hit this cheap ass tripod that I'm using to hold the camera. I'm going to hold it here for about a minute, minute and a half. And preheating the board is a good thing. Don't be afraid to preheat the board. Be afraid to mutilate the board from excessive heat, but don't be afraid to use a slightly lower temperature and keep it on the board. These boards are made to absorb heat, and they're made for a mass manufacturing process, which is worse than almost anything I can be doing right here. The more preheating we do now, from a safe distance, the easier it's going to be to remove the chip and the less likely we are to rip anything off the board in the process. Now, once we actually get close in on the chip, you don't want to start picking it up like this. The reason is, some of these solder pads could be wet and ready for you to remove the chip, and some of them could still be stuck. So if you wind up using any sort of force to remove the chip, you could actually be ripping the solder pads off the board for the pads that are still soldered to the chip. What you want to do once you start heating it up is something like this. You're going to push the chip like this, and once you push it, you know that it's hot. So you go in for the kill and then rip it up. Now, I obviously can't stay there doing that unless I'm using a sample board, since this is a board that I'd actually like to work again. Now, what I did was, first thing I did is touch it. Now, once I see that it moves, I know that every single pad is loose and that I can pull it up. If I were to simply pull this up like that, if I were to simply just take this chip and pull it up off the board, all these pads could be ready to go, but if 2 or 3 pads here are kind of cold, I'll rip them off the board. And then you get into a situation where you're running microscopic wires from this to that resistor and trying to guess also which one of these pads shorts to which components, or going through 70 pages of schematics. Again, things you don't want to do at 2 or 3 in the morning. So just tap the chip enough to move it. As soon as you've tapped it enough to move it, just to ensure that it stays hot and that for some strange reason it doesn't get cold and wind up sticking again, put your soldering iron a tiny bit closer, leave it there for half a second, and then pull it up. That's a safe procedure. Next, what we have to do is work on these pads here, because now some of them, like this one here, have virtually no solder left on them. Some of these have uneven solder joints left on them. I want each one of these pads to have the same amount of solder, or almost the same amount of solder on them. I want it to be even, and I want it to be fresh, with fresh flux. What flux does is it allows the solder to flow. Without flux, solder doesn't flow like a regular liquid. It's kind of like a dirty goo that stays somewhere and sticks. That's why when you're actually soldering something, you should always be adding solder and then taking the iron away. You should never add solder then keep the iron there, because when you see going up in the air, that smoke is actually the flux burning away. And when the flux burns away, the solder no longer flows, which is how you get cold solder joints. A cold solder joint is when there's a crack inside of the joint in some location that keeps it from allowing the chip, the wire, whatever, the lead, or whatever it is from touching the solder pad. Alright, so what I'm going to do is I'm going to add some flux here. This is a Kester 951 no clean flux pen. Yeah, probably can't get it focused in the camera here. It's a pretty cool device. You shake it, and it lets out this flux right along the area. I prefer the pen for these applications. I prefer the pen to just the dropper, because it also serves to wipe off crap on the board, any sort of dirt or anything that's going to keep me from doing my job. So I move this around a little bit. Now I'm going to get to work. Now also, this middle pad, as I mentioned before, that's a heatsink. So think of this like a CPU and thermal paste. That solder blob there is what's allowing the bottom pad of the chip, which creates the heat, to make contact with this. Now, if there's no solder there, it's going to be boiling because the chip is not going to make contact with the heatsink. If there's too much solder there, I'm not going to be able to put the chip on properly, because that solder is going to run out the side and wind up shorting one pad to another and just creating a rabbit mess. So I don't want to add any solder to there if there's a decent amount already there. So what I'm going to do is I'm going to try to solder outwards. I've put this camera at a shitty angle. Okay. Yeah, notice I'm not just dragging one solder blob over them. I'm adding a little bit on each one because I want the flux to be fresh on each one. what you could do as well, you could if you have a good solder like this is a Kester leaded solder with no clean flux inside of it. You could just, do a big ball and roll it everywhere. The only reason I'm not doing it here is because I found with trainees and beginners that when they do that, they always manage to fuck up a pad or get a solder blob somewhere on the board. And if you've seen it in a video before, it is something you can do. I would just discourage doing it until you've done this a couple of times and made it work. Then go along and do it the quicker and easier way. And looking at your work from the top is not going to tell you shit, because we're looking to see that we've got some decent solder bumps on every pad. And looking at it from the top, you don't get any sense of the height or the shape. You just get a sense that there's still silver. It doesn't really help you. One of my personal weaknesses is being a perfectionist. Even if I actually have it so that it's good enough that the chip will sit there and work forever, I still want every single pad to be perfect, so hopefully you're a little less OCD-ish than I am. Because again, I could have been done a minute ago, and why I'm still going about this is beyond me. I guess I just like knowing that it looks good. Okay, I'm happy with this. Now we get to putting the chip back on the board. Alright. Now I like to clean the flux off with a little bit of alcohol on a Q-tip. It makes it easier to see when the solder is finally molten. This tape is beat to shit, so I'm going to put a new set on. Just on these two sides that have all the small stuff. Alright, I'm going to preheat the board a little bit and put my chip on. I like to be right on top of the chip so that while I'm laying it down I can really tell exactly that I'm getting it in the right spot. Okay, it's go time. In the interest of realism, I did put the chip on the board. I did put it on incredibly crooked because I have an unsteady hand, so I decided to heat it again and just move it back into place. There's the theory that the surface tension is enough that you could just drop the chip on there and it'll connect. I wish this were true. I have better luck placing it on the board from directly above the chip, so I'm looking exactly at it so I can see on each end if there's solder pad sticking out. It's supposed to be even. You shouldn't, for example, the left solder pad should not be all covered with the right solder pad showing. You want the chip to be perfectly centered. Now, I didn't put it on perfectly, so I just so happened to heat it again, move it a little bit. Now, the third thing you can do, if you have an incredibly unsteady hand like me, it's kind of cheating, so throw some flux on there. I do this just because I like seeing 100% perfect joints. If you have an iron that's thin enough that you can actually get underneath the chip a little bit, and some good no clean flux solder, you can just do this. This also helps get rid of any small solder balls. Let's say that the heatsink had too much solder on it. Instead of having to go in and redo everything, you just put a little flux on there and do this, and the solder will get absorbed onto the iron. Be cleaning your iron as you go every single time you do this. After that, I'll give it some cleaning with some alcohol. Alright, here's the final part of our video, and the fun part, which is seeing if the shit that you did actually works. So this is the white Unibody Macbook. It doesn't have a hard drive in it. I haven't plugged in anything, no speakers. I can see I got a screen that lights up. So, I'm happy.